Hello everyone, good morning. Am I audible, right? So all of you. So please comment. Good morning, Priya. Good morning, Ini. So I'm launching a poll. So all of you can hear me or not. Let's see. Yes, audible only. Hmm. Okay. Right. Hmm. So today, on behalf of Vinay sir, so I'll be taking the class. Myself, Bharat. Okay. So program associate in Avanti Fellows. So I'll be taking this Parabola chapter. And tomorrow again, Vinay sir will come and he'll be continuing with the ellipse revision. And again, so the next day, next hyperbola, again I'll be continuing with. Okay. The reason is he is on leave today, right? So Vinay sir, he is on leave today. So that's why on behalf of him, I'll be continuing the class. Is it, all of you understood, right? Okay, no? So in the previous session, Vinay sir did circles. So today I'll be doing the parabola, the revision chapter. Shall we start then? Yes, good morning, Sumant. Good morning, everybody. Good morning to everybody. So let's start with this revision sessions of the parabola. All right. So why it's parabola and why need to study? So first we'll understand that. So this parabola and the next upcoming chapters, the previous one, the circles, everything is actually a conic section only. Correct or not? So like in the circles you learned, like you can call it as a conic section one. Okay. So in conic sections first part, so you can call it as a circles. The majorly you'll be learning about circles. In the conic section second, okay. So you'll be learning about parabola, ellipse, and hyperbola. Okay. So here, and if you include the straight lines also, okay, if you include a straight lines, so all these together, so will form a coordinate geometry. Okay, so all these together will form a coordinate geometry. And in your J mains, so this only the coordinate geometry they'll call it as a coordinate geometry in the J mains perspective. And this coordinate geometry, the weightage is given it as almost the 5 questions will be asked in the J mains. Okay, the 5 questions we can expect. They're entirely from the coordinate geometry. So it is in the combination of straight line, circle, and this conic sections part two, that is parabola, hyperbola, right? So all of this together. So that's why when the JMS perspective, you cannot separate straight lines, circles, and etc. But when you're learning, you can separate and learn. But when you go for a practice, just remember that you always learn together. So this is a combination. Okay. So what is our today's focus? Today's focus is this. So this is our today's session. That is parabola. Okay. So this parabola, we can say that we'll get one question. Yes, very good. So we'll get maybe one question may be asked in your session. Sometimes no question will also be asked because like they'll be asking more about ellipse or something else will be asked, right? So you can expect one question, and on average, one question will be there. Okay. So let's understand the beginning with the conic sections first. So did Vinay sir told you about this conic sections, how it started, like a cone and all? So did he mention about this cone? and we have the cross-sectional cutting of this cone. Suppose if we consider this as a cone, yes, cutting of the plane, right, in a cone that with a different angles. So now if I cut just in a like a horizontally in this way, what we get? Okay, you got right. So I'll quickly tell. So what do you think we'll get? Circle. Very good, Ini. So we'll get a circle. Very good, Rahul. So this is a circle. And if I cut in something in a different angle, for example, in this fashion, that is an inclination. Okay. So this inclination, if I'm cutting, so that is actually equal to the inclination of this. This is parallel to this line. In that case, what I'll get? This is parabola. Very good. So this is actually parabola, not ellipse. So this is parabola. So I just skipped one and I asked you checking about ellipse. So this will get it as a parabola only. Okay. So when do you get ellipse? The ellipse that will get when? So when you cut at a slightly different angle, means this is a 0 degree, right? If you consider this to be a 0 degree. And slightly above that, if you do this cutting, no? So in that case, we'll get ellipse. So this is where you'll get ellipse. Okay. So now you just got increased to some degree, right? It's greater than degree. So you want me to switch on the video? Okay then. Because of internet connectivity, I just turned off. Okay, Rahul. Okay, like if you increase one more angle, so then you'll get a hyperbola. Like it can be like this, right? Because it touches a ear also, no? So in a different angle. In that case, you'll get hyperbola. So when here. Clear now? So like this, we'll get different sections. And let's focus on this parabola in today's section. Okay. So there should not be any doubt in this, the conic section cuttings. All right. Like these are the cuttings. If you just horizontally cut circle, slightly tilted, in that case ellipse. And if an angle is actually equal to, so this angle, the cone angle. Okay. If it is parallel to this line. So in that case, we'll get a parabola. And if it is above that, you'll get a hyperbola because it should touch the other part also. Right. So let's move on. So so what is the conic sections that we understood that. So the actual definition is, so it is nothing but the locus of the point. Okay. The entire coordinate geometry has been defined as the locus of the point, right? The path it travels under certain conditions. Okay. The conic section, what is the condition? A locus of the point. Like it has to be, it is distance from the fixed point. Okay. So what is fixed point that we do not know, right? We can fix one point. Okay. So let's call that point to be a fixed one. Okay. So this fixed point and there is a distance to what we are finding the distance. So it's actually the distance to the perpendicular, it's a perpendicular distance from the fixed line. So it means, so there is a fixed line also, right? We have to fix one line here. Let's fix this line to be here somewhere. We'll call this one as a something like a fixed line. Okay. So now what we can do. So they're saying that there is a constant ratio. Okay. A distance from the fixed point to the fixed line. It's a constant. Okay. So this is a free point. Let's call that free point to be P. And if you find the distance from this, somewhere you can mark here so that you'll understand. So this is a free point. Okay. And the distance from this fixed point. So this is the distance. Okay. And the distance to the fixed line. So this is the perpendicular distance. So these two distance, the ratio remains the same. The ratio is constant. Okay. So if I call this fixed, the point to be S and this to be M. So what is that? So PS to PM is constant. Correct. So PS to PM is constant. So that's what the conic sections. This is how the conic section has been defined. Okay. So now instead of calling this as a fixed point, okay, free point under this fixed line. So we'll give it some new names here. Okay, so and those names can you able to recall? So what do we call this fixed point as? Focus. Very good. Is it a focus? So this fixed point, can we call it as a focus? Now use the conic section terminologies and answer it. So this is the focus. So what do we call this fixed line as? Status creator, can you tell? Who is answering? What is a fixed line? Come on, so be quick in answering because we have to complete this parabola in today's class. So be active. So we'll not drag in theory. Okay, we have to solve the question. It's actually the directrix. So this line, we call it as a directrix. Okay. So this fixed line, we call it as a directrix line. Okay. And the constant that we'll get. So this constant we can call it as a E. Boundary. No, there is no boundary. Okay. Some of the new terminologies that you'll be learning are this. The fixed point, what I just called, that we call it as a focus. Remember that. From here, we do not call it as a fixed one. And when I say focus, you have to remember that there's a fixed point that we are talking about. When I say the directrix, that the directrix is nothing but a line. So that is nothing but a fixed line. And the constant which we got the ratio, that ratio we call it as a constant, right? And that constant we call it as a eccentricity. So these are the new terms that you should learn. What is a focus, directrix, and eccentricity? Okay. And the free point which are moving, so we can call it as a moving point or some general point, right? Like that also we can. And another two things. So what do you mean by axis? So here we are not talking about this x-axis and y-axis, not like that. So the conic section axis. Okay. So this axis we call. So what is this axis? Axis nothing but it's a line that passes through the focus as well as it should be perpendicular to the directrix. Okay. Like in this fashion. Okay. So this we call it as an axis. So what is this axis? Axis is okay. It is a line. So which is passing through the focus and also it's perpendicular to the direction. Okay. And there's a point of intersection, like after defining the conics with the axis, we call it as a vertex. Okay. Like you should define one, whether it is parabola, ellipse, or cyclope, right? Suppose if you define one circle or ellipse like this, so it has a it cuts the axis in two different points, right? So that we call it as a vertex. And if you define it as a parabola like this, cutting at one point, that we call it as a vertex, single vertex. Right. So vertex is nothing but it's a point of intersection of the conic. So that the conic can be circle, parabola, right? Ellipse, could be anything. Good morning, Bhaskar. And it should be point of intersection should be with respect to the vertex. Is this terminology is clear? All of you understood the terminologies? Focus, directrix, eccentricity, axis, and vertex. These terminologies will be using frequently. Okay, very good, Rahul. Clear. Nice. Okay. So in general, the entire conic sections is can be represented as in the form of a second degree equation. So this is the general second degree equation. Okay. So it means depending on the condition, it will take a different way. I think you already know what is a circle, right? Can you able to tell me when this second degree general equation will be represent it as a circle. What is the condition? Did Vinesh I told you this condition? When can you call h should be equal to 0? Very good. That is one of the condition. Next, xy term should not be there. That's nothing but x should be equal to 0. And a be 1. Okay. You can, in general, you can call it as the coefficient of x square. No? The coefficient of x square must be equal to the coefficient of y square. B. A must be equal to B. Need not necessarily 1. Like you can take it to be 1. Even if it is not equal, something different number is there. You can always divide that number, right? You can always divide that number throughout the equation. So then you'll get 1, right? But the only general condition, it has to be same. That's the only case. Need not necessary 1. You can make it 1. That is only to bring it in a standard form so that we'll get this g coefficient, we'll get this f coefficient, etc. Yes. And other conic sections given like a parabola. Okay. And this ellipse and other things can also be represented. And it requires some conditions here also. Okay. So that we need to learn what is that. Okay. What is the condition to represent the general equation to be a parabola or ellipse or a hyperbola? Right, it can be done. So let's get into the parabola. Okay. So what do you know about parabola? So vertex. Okay, vertex. If you want to learn once more, see, we'll get a clear picture in parabola. Okay, I'll be telling Amal in parabola the vertex because it requires one of the conic to define. So there we cannot represent in general way. So when using the parabola, I tell you what is the vertex. So what is this parabola? Okay, so this is a simple one. So this is nothing but a conic section. Like so, this has been derived when you cut in a plane, so which is equal to so this conic angle. Okay, isn't it? So if you cut that one in the same angle, you'll get a curve. So this curve is represented as a parabola. Right? Everybody know this. So there is no doubt in that. Correct. So now, but actually we require a new definition, that is the locus definition we call. So this is a parabola is nothing but the locus of the point. A locus definition says it has to be the equidistance from the fixed point and a fixed line. So do you remember what we called for a fixed point? So just recall what is the term that we use for a fixed point. High power focus. Very good, Priya. Correct. So this is a fixed point. So this is nothing but a focus. No? So what is a fixed line? Recall and tell. Directrix. Very good. So this is the directrix. Correct. So it says the distance from the fixed point and the fixed line is always same and it is equidistant. So it means like, see, so let's call this fixed point to be here. That is the focus. Okay. And this is the directrix. It's a fixed line. So this is the curve that we'll get after cutting the conic section, after cutting that, right? And here, so from this fixed point to any point you can take, this is a floating point, right? It's the moving point. It can move in any way. So in this floating point, if you find the distance, so this distance is same as the perpendicular distance from the directrix D. Okay, so these two are one and the same. So this distance from the focus and the distance from this perpendicular distance to this directrix, both are one and the same. It always remains same. And understood? So from here you can see, suppose if distance is given by 7.24, here also you get the same distance, 7.2. Okay, so you need to remember in this way, like, so P F from the focus to the point is same as P Q. Okay, so that's all. So that's what this the parabola makes. And if you remember, in the conic section, we were talking about the constant ratio, right? Point to the focus and the point to the directrix. This ratio is a constant. Okay, understood. So what is this constant? So this constant we call it an eccentricity, correct? Eccentricity E. So what is the eccentricity for this parabola? For parabola, what is this eccentricity? What is the constant that we'll get? Do you know that one? See, as so this distance and this distance both are one and the same. So what is the ratio? The ratio has to be one itself, right? So this PF and the PQ both are equidistant. So it will get cancelled, or you can say the V is equal to one. So hence, for parabola, it is always two. That is eccentricity is always one. Understood? This constant, the eccentricity, that is always equal. That is equal to one. Correct, Priya Rahul, right? So this much you should whenever you hear about parabola, you need to understand that the distance from the focus and the distance to this director is both one and the same. Both are equidistant, and the eccentricity is always one. Correct, no? So this is the most general way of writing uh, the parabola. Y square is equal to 4ax, and everything will be learning from this general equation. And there are other forms also. So we'll be extending that learning to the other forms. Okay. So what are the things that we learned? Like, so one thing is a focus. Correct. So can you able to identify, so what is the focus point here? Y square is equal to 4x. What is the focus? Who can answer it? The point, the fixed point. What is the fixed point for this given equation? I'll call this as a parabola. A comma 0, very good. Is it A comma 0? All of you agree? So you'll get A comma 0. Very good. That's the correct answer. So you'll get A comma 0. So this parabola, so it is in this way. So this is the parabola, right? So y square is equal to 4ax. And if I say there is a, so there is a focus, the fixed point. Okay. So this is the focus. And it's the coordinates of this focus is given by A comma 0. Very good. Very good. That's the correct. So that is A comma 0. So similarly, can you able to identify? So next what we learned? The directrix. So what is directrix? Directrix is a line. So if it is a line, so can you able to identify the equation of a line? Right, this is the line. So you need to identify the equation of a line for the directrix. So that is the directrix is a fixed line, right? It's a constant. So this is the fixed point. Do we get y is equal to minus a, x is equal to minus a, right? So this is the point. This is the line. So this is x is equal to minus a will get. So this is the equation of a line, or we can call it as x plus a is equal to 0. Correct. So it's a line equation. So x is equal to minus a. It's a line equation. So we'll write x plus a is equal to 0. Correct. So now next you can call about, can you able to identify axis? We learned about axis, right? What is the axis? Where is the axis? So axis is also a line. Okay, axis is also a line. Can you able to identify what is the line? No, Amal. So need not necessarily it has to intersect at origin, but so like if you take this equation, this equation will intersect at origin. But in general, not necessary. So where is the axis? Is the axis y-axis? X-axis, correct, Karthik? So just think, do not get confused. So this axis is a line, so that passes through the focus. Okay, you should pass through the focus. So that line should pass through the focus and perpendicular to this directrix. So that is nothing but x-axis. Correct now? For this equation, the x-axis. What is the equation that will represent for x-axis? So y is equal to 0. Correct? So y is equal to 0. So this is our axis. Correct. Y is equal to 0 is our axis for this parabola. So next, what you learned, next thing that you learned about vertex. Can you able to identify the vertex in this? What is vertex? 0, 0. Very good. So this vertex is a point, right? It's a point. Like this is the conic, correct? So what we talked about, the conic means the curve. So this curve cuts the axis. So where it cuts the axis, you need to identify. So it is cutting at this point, right? So this is the point where it cuts the axis. Or you can say that it crosses the axis, right? So this is vertex. So that vertex in this question is given by 0, 0. Correct? All of you understood. The vertex is a point where it cuts the axis. So next one. So can you identify what is a tangent at a vertex? So this is the last one I'll ask. Tangent at vertex. Tangent can be drawn in anywhere. So can you able to find what is the tangent at vertex point? Tangent is again a line. We will say in the line equation. Y-axis. Very good, Priya, all of you, right? The tangent at this vertex is this one, right? So this is the tangent. So the tangent is nothing but y-axis. So right, so it is nothing but y-axis. Or you can say x is equal to 0 is the equation of the line. Correct. X is equal to 0. So these terminologies, if you understand from this basics, like you don't have any problems in understanding in any other formats. All of you clear, Amal? So about the vertex now. So vertex is nothing but a curve. This is the conic. It could be any curve, not only parabola. So if it cuts the axis, then that the point we call it as the vertex. Okay. So next, moving forward, I think we are doing a bit slowly. Let's do this so that we have to solve the question. In parabola, there are different forms of it. So one of the form is this one that we just discussed about vertex, focus, the equations of the directrix, axis of the equation, right? Tangent. Okay. So you need to understand that this vertex and focus are the point. Okay. And this equation of the directrix, equation of the axis, equation of the like tangent to the vertex, all are line. Okay. So you need to identify. So what is the line? What is the point under, right? So this line equation when it comes, you need to write. You can express in terms of y is equal to mx plus c. So that is a good way to represent. And there are other forms also like this. You know. So these are some of the standard forms. And beyond this also there it will exist where the vertex will shift away from the origin. So in all the cases the vertex is 0, 0. When the vertex shifts and the focus also shifts, right? That shifting will do the later part. Correct. So that was the thing. So no. So for a parabola, you have a unique vertex. For one equation of the parabola, you get only one vertex only. One vertex, one focus. So everything, all of these are just one only. So one vertex, one focus, one directrix, one axis, and one tangent at a vertex. Well, it could be multiple tangent at a different point. So that is a different form. So any this parabola can be represented in the parametric form is the most the useful form in this parabola. Okay, the parametric equation, right? Like this is the general point you can consider. This is the general equation of the parabola. The parametric condition says instead of taking t as x comma y, it is advised to take in a parametric form the p as at square and 2at. Okay, so at square and 2at. So where t is the parameter, we are substituting instead of x as a at square, and automatically y becomes 2at. Correct. So here there is only one variable. Since a will be as given in this equation one itself. T is the only unknown variable, that is the parameter, right? So that can be found after substituting here. Whereas if you take p is equal to just x comma y, just like in a Cartesian format, it has two variables like x and y, both are variable. So it is difficult to find. Whereas if you take in this way, it's easy to find because it has just one variable, that is t, can be found in. Okay, like when you're problem solving a question, like try to use this one, the parametric form. Okay, so some of the points I'll be sharing with you, all the important points that comes in this parabola, and then we can apply the everything in the problem solving, right? So next I can new terminology that you will be learning is the lattice rectum. Okay, so lattice rectum is nothing but a chord. So but now the question comes, what is a chord? So what is chord? Like in the circle also, so that word you come across, like, so the circle also you learned what is this chord. Not actual definition, but you can say some lines like, so this chord is nothing but, for example, in a circle. So there are 2 points are there in a circle, and if we join these 2 points, so that becomes the chord. Any 2 point, correct? A straight line, very good. It's a line. So by joining 2 points, and in circle, the biggest chord is nothing but the diameter. All of you, right? The biggest chord is the diameter, and other chords will be like smaller than its diameter. So here also in the parabola also there is a chord is there. Yeah, correct. And in the parabola also there is a chord, right? So like, so you can represent, if I write some bigger diagram. Okay, it can be in this way. It can be in this way, right? So these are the chords in general, right? So these are the chords that. So if you take any 2 point and like a join it, you'll get a chord, right? So that is a chord. But what is the difference? So the lattice rectum is also a chord. It is one of the special chord, right? And but this chord is actually passes through the focus, right? The same chord we can call it as a lattice rectum if it passes through the focus, as well as it should be perpendicular to the axis. Okay, that is a two important condition. Like any chord, we can call it as a lattice rectum if it passes through axis. So if it passes through the focus, so this is the axis, this is the focus, and it should be perpendicular to the axis, right? So this has to be correct. So this chord becomes equal to the lattice rectum. We'll call it as a LR in short form, right? That's a lattice rectum. All of you clear what is lattice rectum? And there is a standard result that, so what is the length of this lattice rectum? Okay, the length of this lattice rectum is nothing but, it's always equal to 4a. Okay, so it is always equal to 4 times of e. Okay, so that is 4 times of a, it will be equal. For a given equation, y square is equal to 4ax is the given equation. The length of the lattice rectum is given by 4a, or you can say the double of the focus, right? If the focus is a, like this distance will be a, right? So this distance will be a. So this distance will be 2a, and this distance will be 2a. So in total, we'll get 4a. Understood? The length of a lattice rectum. or you can just see there is a Fourier term will be there. For example, if I say y square is equal to 6x, so this is the equation of the parabola. What is the length of the lattice sector? Just by looking at it, we can say the x coefficient generally will be 4a only, right? So this itself is the answer. So what is the answer? It's a 6. Can we say the length of the lattice sector for this parabola is 6? Correct. Correct, Nakarthi. That's simple. Yes. So there are other important points, like these are the things. Okay. Some of the important lines you can just remember that for any chord to the parabola, okay, it is always which is perpendicular to the axis is always is double the ordinate. Okay, it is always the double the ordinate. What does it mean? Like this point, right? So this is the point. Let's say. So what we are talking any chord to the parabola which is perpendicular to the axis. We are talking about any chord, not only lattice vector, but any chord. If I extend this further, and if I write a chord here, so it's a perpendicular to axis. Can I say like that? And it's the end point. If I call it as a B, so what is the ordinate? The ordinate will be the double of it. Will always be 2B. Understood? Or when it comes to lattice rectum, so this point is actually A, and the y coordinate will be the double of it, that is 2A. Okay, and here, so here it becomes A. The y coordinate is, but because it lies below the x-axis, it will write minus 2A. So hence the total length will be 2A plus A, 4A. What about here? So this point will be like B, comma minus B, comma minus 2B. So hence this total length will be 4B. Isn't it? Understood? That is always true. So for any chord which is perpendicular to the axis, the condition is it has to be perpendicular to the axis. Then only we can say like that. Understood? So next, if the 2 points are said to be, 2 parabolas are said to be equal, if the lattice rectums are equal, then we can say the parabolas are equal. So simply we can just find what is the lattice rectum. If the lattice rectum is equal, parabolas are equal. That is also true. Like if I say y square is equal to 6x is one parabola, and if I say y square is equal to ax is another parabola, and say these two parabolas are one and the same, what do you say? A has to be equal to 6. It means A is here, it is lattice rectum of the second one. Here 6 is the lattice rectum for the first one. Both has to be same. Yes. So these are the important points you need to know. Right. About a lattice rectum. That lattice rectum is nothing but a chord. Right. And that chord can be any chord. So here we can talk about the focal chord. The name itself is a chord that passes through the focus. As simple as that. Correct. The name says it's a chord that passes through the focus. Need not necessarily be the perpendicular to the axis, just like in lattice rectum. It can be anything. It passes through the focus. Okay. In that case, how do we find the focal length? Yes, this length, this entire length. Any idea? Do you know any idea about how do we find this focal length of the parabola? No idea. Shall I tell? Is it clear now? Like understood, right? What is a focal chord? Focal chord is very simple. Anything that passes through this the focus, and the length can be found easily. Okay, like you can call it as the focal distance, right? The focal distance. So we like if this is the focus here, correct? And this is the distance that we need to find, like TS. This distance had to be found. Like for a given equation of the parabola, y square is equal to 4x, we have to find what is the length that we call it the focal distance from any point. So like that can be found easily. So this length need to be found. So do you know from the definition of the parabola? So this length is same as the length from this directrix. Correct. The perpendicular distance from the directrix both are one and the same. Can you say like that? Because they are equidistant, right? So we have to find what is PS. And we also know that the PS is nothing but PM. The focus means the distance, perpendicular distance from the directrix. And this perpendicular distance for this parabola, you know that PM is nothing but equal to. So this distance that is ZN, correct. So that is equal to the ZN. And this ZN, so we can split it into two parts, saying that it is ZA plus AN, right? ZA plus AN. So this ZA, this distance we already know. This distance is same as this focus distance. So we can call it as A. So that is an A. And so this up to here, we do not know what is that, right? So if we call the speed to be x comma y, so this is the x coordinate that we want to find. If they given this any point, right, this is the given point. In the given point, x and y comma will be given. So if we take the x coordinate of that, so that will be the answer. Just as simple as a plus x. Okay. So if I say y is equal to 8x square is actually the equation of the parabola. For example, how questions will be asked? Y is equal to 8x square. Okay. So this is the question. And in this question, they'll ask find this focal distance from some different point. Let's say this 1 comma 2, like that may be given. It has to satisfy. It has to be inside 1 comma 8 maybe. Right. So this is like this the question may be asked. How PS, PM, and PM. So this is from the definition. So these two are from the definition. PS is equal to PM. Okay. So this is from the definition. It says the means from any point on the parabola, the distance from the focus is same as the distance from the directrix, the perpendicular distance from the directrix, isn't it? So this is from the definition of the parabola. So what do you say? And this PM is equal to PN. So PM is equal to PN. That is okay. This is not PM. This is a PM. PM. This is Z. I wrote this ZN, right? That is ZN. That is. So this distance and this horizontal distance, both the horizontal distance are one and the same. This is actually ZN. And this ZN can be split into ZA and E. Correct. So what is this answer? So I asked this question, what is the focal distance from the point 1 comma 8? Given that the equation of the parabola is this. Diagram is confusing. Really? Okay, if I write neat diagram, okay, listen here. So this is the parabola. Okay. And understand there is an axis. So this is an axis. Correct. And understand there is a directrix. So there will be a directrix. There is a directrix. Okay. Okay. So diagram may be confusing. And we need to find where is the focus. The focus, let's keep the focus here. Yes. Okay. So this is the focus. Right. So what is the specialty? So like, so this distance, if it is A, so this distance must also be same, right? A. So that's what the directrix is all about. X is equal to minus A is the directrix. and the focus we call it as a comma 0. Right. Next, what is required? So next, so we can take any point on the parabola. Okay, we can take any point on the parabola here. Okay, so hmm. So if we take any point on this parabola, let's say this is a point P, and they're given x comma y. Okay, so this is that distance, right? So this distance, so this PS distance has to be same when you draw the perpendicular distance to the directrix. So that is the definition of the parabola. Okay, so we can write this PM, right? So this distance PS must be same as PM. So that is the definition. This is from the definition of the parabola. It is always true for any parabola. Correct. So the next thing, the remaining part is just draw one perpendicular line here, so that we can call this one to be N, and this is a Z we can call. Okay, so we can say that this PM is nothing but Zn, means on the axis. We just found that this distance must be same as this distance, and this Zn is a combination. We can call it as this Z times this A plus and A times N, the distance A N. Okay, so this ZA, so this distance ZA is nothing but A, as you see in the diagram, plus AN, right? AN we do not know. Like if I call this one to be a vertical y-axis, right? This is vertical y-axis, and this N is nothing but this distance from the, isn't it? So this is x coordinate. So this is x coordinate for the point P. So hence, we'll write it as x. Okay, so hence the focus distance is given by, so this A plus x. The focal distance from the focus to any point on the parabola is always equal to A plus x. Okay, now understood, everything clear? Fine, nice, nice. So the most important part in the parabola as a theoretically what you need to learn in combination, like the parabola and a line. Okay, so parabola and a line. So this line can be any line. So this line can be like uh, a line that intersects the parabola. Correct. A line that intersects the parabola. It can be a line that touches at the only one point, right? It can be, so that we call it as a tangent, correct? And the same line may pass perpendicular, perpendicular to this tangent, that we call it as a normal, correct? And the same line can also be a chord, correct? So joined with inside the parabola. So these are the different things. A parabola, the equation will be given, and a line may be given or not. And they may say some conditions like, so that this given line will intersect the parabola, or this given line is a tangent to the parabola, or find the normal. This is the chord. So these are the different things. Correct. So you need to understand all of it. So how do we intersect tangent, especially this tangent and chord are the two important ones. Means every time they'll ask these two ones. Okay. Yes. So let's start with this tangent itself. So tangent is a line. All of you should know that is a line that touches the given parabola at only one point. So that we call it as a tangent. Right. So suppose this is the given equation of the parabola. Y square is equal to 4ax. How do we write a tangent to it? How do we draw the equation of a tangent? How do we write the equation of a tangent? Okay. For a given parabola. How do we draw? Suppose this is the point at which the tangent is there. Okay, so it is touching at only one point. So this is the equation of the line, correct? Which touches this parabola at single point. So this line becomes tangent. Why? Because it touches at only one point P, and let's call that point as x1 comma y1. Okay, so let's call that point as an x1 comma y1. So in that case, directly we can able to write the equation of a tangent just by using the some method, that is the replacement method. Okay, so we call, like in the circles also you might have known. So whenever this x square is there, you replace that x square with x1. Correct. Whenever y square is there, you replace with y1. And wherever we have just x, so we replace that with x plus x1 by 2. Wherever y is there, we replace that with y plus y1 by 2. And wherever constant is there, we do not do anything. We just write constant. Do you know this method? Right? Do you know this method? The same thing we'll do here. Okay. So this is the equation of the parabola. Right? The equation of the parabola is given by y square minus 4ax is equal to 0. So this is the equation of the parabola. So we can call that one to be yes. Okay. Like equation of any second order degree equation, you can call it to be yes. So yes indicates a second order some equation. And here it is parabola. So now we can call this t. T is a tangent. Okay. The tangent equation we need to find. How do we do? So in order to find a tangent, a point of tangency needs to be given. Okay. So this P is there, right? So this is the point. This is, we call it as a point at which the tangent occurs. You know, the tangent point. When this tangent point is given, means this point will lie on the line as well as on the parabola, isn't it? X1 comma y1. So in that case, we can able to write the tangent equation directly using this method. Wherever this y square is there, replace that with y1. Isn't it understood, all of it? Minus 4a as it is, the constant as it is. Where x is there, what we should do, we should replace that with x plus x1 by 2. X plus x1 by 2. Okay. X plus x1 by 2. Understood or not? So this is equal to 0. So this becomes the tangent equation. Right. So hence the equation of the tangent. So what is the equation of the tangent is when the point at which the tangent occurs, x1 comma y1 is given, we directly write y1 minus 4a. 4a can be simplified as 2a times x plus x1, right, equal to 0. You can write it here. So this becomes the equation of a tangent. See, as given here. Did you understand the method? So this works for any curve, not only parabola, not only circle, for all the curves. So this method will work. Okay. So this method can be applied when the point at which the tangent occurs, if it is given, and the given the curve is a second order degree equation. So write the second order degree equation, yes, and wherever this x square is there. So these are the terminologies that will occur, right? So you can do that method, you get a tangent equation. Understood? So next I can talk about if the point given is in the, if you take in the parametric form, like at square 2at in that case. If you take in the parametric form, um, Any doubt here? A line which joins 2 points of the circle. No, I didn't get. So next, a slope of a tangent. So that can be given in this fashion, right? So this becomes the slope of a tangent. So, so whenever you want to find a slope, you can, the most easiest method is just differentiation, right? You can apply the calculus. So there may be other method also. The coordinate geometry will tell. Like when you are in the 11th class, you are using that. Now, after understanding the differentiation, try using that also, right? So whenever the curve is given, and if you want to find some slope, differentiate it. And at what point we have to find, after apply that point equation, you'll get the slope of a tangent at P can be found easily. Understood, right? Correct. So once you know the slope, we can able to find the equation of a tangent easily. So equation of a tangent is given. So this is the slope form, as the students were telling. I think this form is the easy one, right? All of you know this. Correct, Tejas. So this we call it as the slope form of the tangent. The previous one, it was a point one, where the point has been given. So here, if the slope has been given, the slope can be found easily. It can be used. This method can be used. Y is equal to mx plus a by m. Correct. So when to use the point and when to use slope, that depends on the question. All of you understanding? Okay, good. So we talked about a tangent. Is it clear? Understood the tangent. A tangent is a point where it cuts at the only one point. Right? It can be in two forms. One is in the point form, I told, and other is a slope form. So now, a line can also intersect, right? Means it just cuts the parabola into one or two parts. Right? It is an intersecting line. So please so this is the intersection line. Means the line will intersect. So when if it intersects, what you should do? Like it should cut at the like a 2 points. If this is the parabola and if this is the line, correct. So this is cutting at these 2 points. So these 2 points are the intersecting points that can be found. So just use this method. What is that? In the equation of the parabola, and this is the equation of a line. So substitute this y in this equation. Okay. We can there is only one method. Just substitute this y into this equation, and then you'll get a quadratic equation in terms of x. Okay. Do not worry about this big term. Just understand the method. Method is parabola equation will be given, line equation will be given, and they say these two intersect at this line intersect a parabola. If it intersects, substitute that line in the given parabola, and you'll get a quadratic equation either in terms of x or in terms of y. We have to solve this quadratic equation, right? And since like using a discriminant method or in any other method, if you want, you can try by solving a quadratic equation, you'll get your answer. Okay. Means what is the coordinate? The x coordinate and y coordinate will be found. The x coordinate either plus or minus some value will get. Here also plus or minus means one is a plus and other is a minus and two coordinates will get. Correct. Understanding now. So whenever intersection comes, so we should know this method. Next, we can also derive the condition of this tangency just using the previous one. Okay. The previous one, I told you that if a line cuts the parabola in this fashion, it's cutting at 2 points. And the same can be extended further and say it as so instead of cutting the parabola into 2 points, it may just touch the parabola like this. Right. So this becomes the tangent. The same line is converting into tangent. How that happened? So here there are 2 points, right? So these 2 points becoming just a single point. So can we say that the root of this quadratic equation that we just saw the previous one, So this quadratic equation, the root of that quadratic equation is now same. Both are equal. If the root of the quadratic equation is equal, then when do you get equal? So when you take the discriminant equal to 0, the discriminant of this quadratic equation to be equal to 0, then we can say the root of the quadratic equation are same. So this becomes the condition for tangents, right? So that's how the condition for tangents has been derived. So as of now, it's not that much required. Okay. So as of now, just because we just know y is equal to mx plus c is the equation of a tangent, the equation of a line, which is a tangent. Correct. It's always true. So this is always true. So this is the derivation is done by using the condition for tangent. Okay. So this condition should be known to you. C is nothing but a by m. Okay. And similarly, the point of contact can also be found like the tangent is there and the point where it meets the tangent. So that can also be found using this method. You can take the parameter t and then find out. We'll get the point of contact in this fashion. That is a by m square, comma 2a by m. Okay. This also can be remembered. Otherwise, not required. You can just solve it and then find the point of contact. Or if you want to save some time, you can directly use this result. Right. We can directly use this result. See, when I send the notes, go through all of it. Okay. When I send the notes to you, go through all of it, the theory part. All right. And see, I told you the line can be tangent, right? Intersecting, or it could be a chord. Correct. If it is other than the tangent, it could be normal. Normal can be found easily. And the most important one is this tangent and a chord I was telling, right? Now understand this chord also, the line. Understand this chord also, how to find the equation of the chord. So this is also a line. What happens? Like I'll tell you how we can able to do that. Yeah, something should be given. The equation of a chord if the midpoint has been given. Okay, if the midpoint has been given, just like this. So let's call this P to be the midpoint of this chord AB. It means it is the dividing this chord in the ratio 1:1, right? Because it's the midpoint. This line segment is dividing this point AB in the ratio 1:1. If this point has been given, if the point A and point B has been given, this midpoint can be found easily. Or if the midpoint is given, so this can be extended further. And the point A and point B can also be found. Right. But I'll tell you the direct method how we can do. So this directly will get this result. So this is the equation of a chord when the midpoint x1 comma y1 is given. Okay. How do we get this? In a simple way. See, when the equation of the parabola is given, write that one in the second degree equation. Okay. In the second, how do we represent like a given curve in the second degree equation? Like it should be in this form, right? X square plus y square plus 2gxy, right? In that format should be there. If I rewrite that in that case, so I'll call it as yes, and I'll let it as y square minus 4ax. So there is only this term at the remaining, so this will be equal to 0. So call this one to be a. Yes, S is a second degree equation. So do you know how do we represent t? T is a tangent, right? The t always represents a tangent. So the t equation can also be found in a easily. How do we write t? y1 minus 4a times x plus x1 by 2. Do you recall this one? I just told you. Now, once you found this s and t, so we can just use this t is equal to s1 format. Okay. So t is nothing but y1 minus 4a times x plus x1 by 2. And s1, yes, we know already. But s1 indicates a point after substituting a point. Right? After substituting a point, the point to substitute is y1 comma x1, right? x1 comma y1. If you substitute that you'll get y1 square minus 4ax1, isn't it? So this itself, the equation after solving, you'll get the equation of a chord. Okay, so this is a number that you'll get because after subtracting a point, you'll get some number, and the variables are x and y. X is there, y is there. These are the variables. So from here, we'll get our answer. Is it clear? So S1 is after substituting a point, given point, that is a midpoint, S1 is equal to y1 square minus 4ax1. Understood? How do we find the chord equation directly when the midpoint has been given? When the midpoint has been given. So this is the thing that you should use. So why we use this equation for a chord? Means we have to find the equation of a chord, right? So this is the equation of a chord. This is the chord. In the given question, if the question is given, find the equation of a chord means, and the midpoint has been mentioned. Even if the midpoint has been not mentioned, this end points has been there, we can able to find the midpoint, right? Because it divides in the ratio. Once this midpoint x1 comma y1, if this midpoint has been there, we can directly find the equation of a chord. So just use t is equal to s1. We should know what is t and what is s1, right? So I told this. Okay. So there are another way. The chord of contact also will be there. The chord of contact is much different from the chord. Okay. See, when the external point x1 comma y1, if it is mentioned, right? So like we can able to find the two tangents to it, right? So what do we call this is a tangent one, and this is the second tangent. Correct. So these two tangents, so they are this is the point of tangent. Okay. So this is the point of tangent. The point where it meets the curve at single point, and this is also a point of tangent, point A. The point of tangent, I can say the second tangent, this is the first tangent. So now if these two tangent, these 2 points are there, right? And if you draw a line using these 2 points A and B, so you'll get a chord, correct or not? So this is a chord. So this equation of the chord can be found easily. So like, you don't need to worry too much about it. So like this point has been mentioned directly from the external point x1 comma y1, if it is mentioned that they asked to find the point of contact. So what we should do? Indirectly we can write this equation. So this is our required the chord of contact equation. How do we get this? In a simple way. So like t is equal to 0. A simple way to say it's nothing but t is equal to 0. But what is t? As previously I told, yes, what is yes? Yes is a second degree equation. We'll write it as x y square is equal y square minus 4ax is equal to the second degree equation. What is t? T is nothing but y1 minus 4a times of x plus x1 by 2. Correct. So this is the t equation, and this is the second degree equation. So now if you equate the equation of the tangent t equation, and if you say it equal to 0, so that itself gives you the chord of contact. Okay. This itself gives you that chord of contact in a simple way. Like, so so this is the tangent equation, and if you are equating the tangent equation to equal to 0, how do we get the chord of contact? Then how it is different from the tangent? Can you able to answer? So this is actually the tangent equation. How the tangent equation is different from the chord equation, tangent versus chord? Who can answer it? For both the cases, I given the same equation, that is t is equal to 0, t is equal to 0. How? What is the difference between them? Who can answer it? What is the difference? So do they have a common point? No, no common point. See, the chord is nothing but no tangent points are always perpendicular to focus. Maybe. See here. So we can use the same t is equal to 0, t is equal to 0 equation on for both the cases. But when to use the tangent and when it becomes a chord means. So here that depends upon the point. Okay, the point x1 comma y1. Here, this point should be given it as the point of tangent. Okay, the point of tangent. And here, for a chord, the point P, x1 comma y1, it is not the point that lies on the parabola. It is an external point. Okay, that is lying outside the parabola. Understood? So you can see here. So this point is lying where? Outside the parabola. So that is not lying here. But if I say this point P lies on the parabola, so then we can say that this we can use the same equation and we'll get the tangent equation. That is PB will get the tangent equation. But since the point is lying outside, when you use the same equation, the equation that you'll get is actually the chord, not the tangent. Right? So understand where the point is given. If they mention the point of tangency, then if you use this t is equal to 0 equation, you'll get a tangent equation. And if they mention this is the external point, and if you use the same equation, the t is equal to 0, you'll get a chord of contact equation. Understood? Okay, in order to make you confused, 12th class they are given the same equation for a chord as well as a tangent. If the students, if you're they're smart when to use when, then definitely you'll win, right? So this is the last one that I want to tell you in the theory. Okay, almost time also. That is talking about a pair of tangents, like a pair of tangents given to a parabola, right? Directly we'll get there is nothing in that. So this is the thing. Okay, so suppose this is the point. This is the parabola. Okay, and so what is there? There is an external point as they mentioned. Okay, the P of x1, y1. And so if I join from this point, I can draw a tangent. Correct. I can draw a tangent to this at let's say point here. And I can draw one more tangent, correct, not here at point. For a given parabola, so these are the two tangents. So this I can call tangent 1 and this is tangent 2. So these two tangents can be drawn, right? And so that tangent equation can be found easily, like directly. If this is the equation of the parabola, and I need to represent that in the standard second degree equation, and I'll say it as y is equal to y square minus 4ax is equal to 0. Correct. And I can find what is S1. S1 is given by y1 square minus 4ax1. So this is not actually equal to 0. It is not the case. We'll get one number. Okay, it will get some number. And then if you multiply these two, yes, S1, this is yes, and this is S1, right? So what is this is yes, and this is S1. If you multiply these two, you will get a tangent. So this is T. You should also find what is T. T is nothing but y1 minus 4a times x plus x1 by 2. So this T and make it a square. Okay, so this after solving this, you'll get a pair of straight lines equation, a pair of straight line, or you can say the tangent. So this equation is a pair of lines or a tangent equation. Understood? No? So like yes, so I did all the theory part. So I thought of solving the questions also, and I prepared. Right. So like the summary is done. So it's problem solving subject. What I do, I'll just when I send the notes, no? So in that I will share the along with the solution also will be there. So just read the theory what I just told. Using that, we can able to solve this much, right? See, all the questions are the latest ones. JEE Mains 2021 questions are there, and try to understand the question. Try to solve it on your own. Okay, I could have done one or two questions here itself, but since we have less time, we'll end the class here, right? And if any question, if you didn't understand, you can just send in WhatsApp. I'll share solution to you, right? You try this one, okay? So try it at home. Okay then. So bye everyone. Bye bye. See you next class. Tomorrow Vinesh sir will take the ellipse chapter, and again I'll come with the hyperbola. Okay. So he is on leave today and also on Friday, but Thursday he can take classes.